All right, there should be recording. Okay, so for number one, says the following table shows some wind tunnel data for force versus wind velocity. This is your data. And then it first says plot the data in Excel. So hold up, yeah, no problem. Okay, so we have the data here, right? Ignore this for now. So we have the data here, copied it down, and then you just go highlight the whole thing, click insert, and then you pick one of these. Doesn't really matter, right? And then you add the chart title and the axis titles, but you could do that,
right?
And then it says select the third order polynomial to fit the data. So you go to trend line here, go to more options, and just click polynomial, and then third order here. So, and oh shit, I forgot to add the. Where'd it go? All right. Let's click the line. Did I click the line? There. Okay. So you add display equation and display r squared value. So now we have our equation here with the r squared value. And that's pretty much not done for part one there. For part two, it tells you to use Excel solver or goal-seek to estimate the value of the velocity when the force F is equal to 2000 newtons. For this part, find the polynomial coefficients with the regression package to ensure the accuracy of your answer. So for goal-seek, which was I use solver, but you could use goal-seek, it's the same thing. For either of these, you need an equation, right? So you pretty much just give goal-seek an equation and then the variable, and then it changes that variable so that the equation is equal to whatever value or maximizes or minimizes it. So what you need here is an equation. Oh, did I mess it up there? All right. Yeah, messed it up.
What? How do you get to the? How do you form the equation?
Okay, so this is the equation here, but if you just type in these coefficients, it's probably going to be very inaccurate, like she did in one of the classworks, where it was just off. The numbers were off from the actual graph because we don't have.
Let me just say really quick. My mistake with the formula was I switched the 90 with the x's. So instead of squaring the x, like instead of squaring 90, yeah, I was squaring like B, C, and D. Oh, or like however
you're squaring the coefficients.
Yeah, no, like it was all the same. It was that, but since I had gotten out of work and I was just, my brain was fried, like that's what my mistake was. So when you do it, make sure you're clicking the right thing.
Yeah, you're squaring the right thing. That. All right, so this is the equation. Yeah.
All right. How do you get the how did you get the intercepts and the coefficients? Did you do the data analysis?
Yeah, the least square regression thingy, which is what I'm gonna do now. So this is the equation pretty much that you have to put in here, right? But you don't have the entire coefficients and you can't just copy them straight off of here and put them here. So what we do is the least square regression, right? So this is going to be the form of our equation pretty much. It's the same thing as here, just with A, B, and C, and D, and X's, right? So I really don't know like why you do this here, but that's just how it is. If you need more explanation, like watch the classwork, because I honestly don't know why you do this with the squares and then stuff. But what you do pretty much is just obviously have a line of ones. You don't really need it for least square regression, and then have each of these values of x, or in this case they're v, but have each of them in a line in a row here, and then just square them and then cube them, and then have them like that. You see, so here I'm just squaring this one and then I drag down the equation, and then for this one I'm just cubing the x and then just dragging it down as well. And then these are the values here. All right.
That's your y values, I'm assuming, right?
Yeah, these are the y, the f values here. Again, I don't know like why you do all this, but that's just how it is. So if I remember correctly, it's here, data analysis, regression right here. Click OK. Okay, so the Y range would be these Y values, right? So the F values here. The X range are all these right here. Oh, you can even include the labels. Just and then just make sure if you're putting the labels, just click labels. And in this case, we don't want it. We want a constant here. So we don't put constant equals 0. So you could add the residuals, but she doesn't ask for them in this question, but just put them there anyways, I guess. And then click OK.
My bad. The X values. What were they?
Hold up. All of these, all of that.
Got it. Thank you.
Yeah, and these are the Y values. So now it's just going to give you this whole analysis sheet, and you could pretty much just take this and just copy it and put it back in here, so you have access to here.
Yeah, dude. When I was first doing it, I couldn't figure it out, and that's because I was only using X. I wasn't using X squared and X cubed.
Yeah.
But yeah, that makes sense now.
So if you want, make sure to write that down on a paper, like for when you're actually doing the exam or something. She said you could have, you could have handwritten notes, I guess.
Right.
So make sure you write that down if you think you're just gonna forget it.
Have you guys heard anything about the test from anyone else about how it's gonna be?
No, actually, I haven't. So, well, now it says. So now we have the actual equation with the exact coefficients, right? So now it's just. So I put 90. I think someone asked in the chat like why I put 90 there, but I just guessed because. So. Yeah, I just guessed 90. It was just
you just put 90 there on the solver thing, like.
Yeah, it's just a guess. It doesn't really matter.
And the next number.
And then this number. Okay, so what I did pretty much was just take this equation. Wait, equation. All right, so let me rewrite it actually. So the equation is this right here. This is the equation of the trend line, right? That estimates the data points, right? So if we plug this equation in here and plug in 90, we should get an estimate of what the force is at 90, right? So if we follow this equation, we just take, you see it, this one times the x here squared. Oh, squared. I mean cubed. Sorry. Minus. In this case, you would add because this is already negative. So add the coefficient times, and then the x is at B15, but can't see it, so I have to write it down. The x squared, right, plus the 15.396 times B15, that's where x is, and then plus this last coefficient here. And then you just click enter, and then you get this value right here, right? So this is just to give solver or goal seek a starting point, pretty much. So now you just go to solver. So now we want this cell to equal 2000. And for that to equal 2000, we want Excel to change this value right here, right? And that's it. You just click solve, click OK, and then now you have your value here. So now when the force is equal to 2000, the velocity is 89.479. And that's the value pretty much that it's asking for. To estimate So we're estimating the value of the velocity when the force is equal to 2000. And this is the value right here.
Got it.
So that's it for number 1. And this is just what I got last time when I did it. Actually, let me just delete this one right here. All right. So now for problem 2, this one kind of caught me off guard. I was kind of confused, but hold on, give me a second. All right, so we were given these 3 equations, right? And we have all these values that they give us. So they give us all the K's and all the P's. So we only have 4 variables here that we need to figure out: U1, U2, and U3. And since this is a system of equations, if we have 3 variables, we need to have 3 equations, which is what we have here: 1, 2, 3. So I'm just gonna open Word here real quick. All right, so they give us these 4 equations. I don't know. So they give us these 4 equations here. So what you want to do is first separate the constant here from all the variables. So what you're going to do is set P1 equal to, and you're just going to move all these constants along with the coefficients here, because these are the coefficients, over to the right side. So if we add U1 over to the right side, it's going to be K1 plus K4 plus K5 U1, right? And then if we subtract U2 over to the other side, it'd be minus K4 U2. And then so do the same thing with U3, just move it over to the other side. So minus K5 U3. So now we're going to do the same thing with the other ones as well, separate the constant from the variables. So P2 is equal to, move this over to the other side, it'd be negative K4 U1. If we move U2 over to the other side, it'd be plus, because there's a negative here, plus K2 minus K4 plus K6 times U2, right? And if we move this, the U3 to the other side, you subtract K6 here. You subtract U3, well, K6 is the coefficient. So just take it to the other side like that. And we're gonna do the same thing for the third equation here. Separate P3 from the variables. P3 equals, if you move over U1, you get negative K5 U1. Move over K2, it's negative K6 U2. Oh, hold on. Negative K6 U2. And if we move over K3, it'd be positive because you're adding here. So plus K3 plus K5 plus K6 plus K7 plus K8 U3. So now we've ordered our equations, right? So we have this, now we have these, which are in order, which is what we're gonna need to do here. So we are given all these variables, so we just put right all of them down here. And now we have these equations. So our coefficient for U1 here is equal to K1 plus K4 plus K5. So that's gonna be our first box here in our matrix. So this is set equal to K1 plus K4 plus K5, which is C3, C6, and C7. And it's the same thing here for the coefficient of U2 is just negative K4. This is K4, so set it to negative C6. And then you do the same thing for U3. It's negative K5, so it'd be negative C7 here. And then do the same thing for the other two equations. So here would be negative K4, K2 minus, it'd be positive because there's a positive here. There's an addition symbol here. So it'd be K2 minus K4 plus K6. And then you just do the same thing for all the other ones too. So for U3 here, it'd be, hold up, K3 plus K5 plus K6 plus K7 plus K8. And that's your matrix. These are all your coefficients. And if you were to multiply it by the variables, you should get this. Right? These are your p-values here.
Wait, hold on.
Right. Can you go back on that one? I didn't get that part.
And what you just said about the values you have there, the last three?
These?
Yes.
All right. So our equation here is this matrix C. This is also in a PowerPoint. I forget which one, but here's our matrix C, and these are our variables. These are our x's. And if we multiply the matrix C times our x's, we should get the resultant here, which is the other side of our equations here. See P1, P2, and P3. You see, if you were to multiply this by these, you get this. So let's say you were multiplying this matrix multiplication by hand. So you would be doing 8,500 times U1, so 8,500 times U1 plus, or it'd be, in this case, it'd be negative, so negative 1,000 U2, so you're multiplying this by this, plus negative 2,500 times U3, sorry. So minus 2,500 U3, and then that would equal this first row right here, 1,000. And then you would do the same thing for the other ones as well. So it'd be negative 1,000 times U1
Okay.
plus 1,000. If I can write 1,000 U2, and then plus negative 500 U3, and then that would equal your second value here, 2,000. And then it's the same thing for the bottom row as well. So negative 2,500 times U1 plus negative 500 times U2 plus 11,500 times U3 is equal to this right here.
And the order of the matrix, can you repeat it again? Like, how do you, for U1, I'm assuming you multiplied K1, you add K1, K4, and K5, and that's
On this one right here.
yeah, that's the first value. And then, for the second equation. Okay, gotcha.
Negative K4, yeah.
Yeah.
So you see how I ordered them? U1s are all first, and then U2, and then U3. So that's U1,
That's the same
U2,
thing.
U3. Yeah.
Gotcha.
So like I said, that's what it's technically, if we had numbers here, that's what it would do. Actually, let's do it right now. So
Wait, can you pause just super quick?
yeah.
Because I'm writing down like all this as you're talking.
Oh, okay.
Just like super quick, because I can't focus on both. I'm sorry.
Yeah, that's fine.
I'm almost done writing it.
Yeah, I'm just gonna multiply it just so you know, like if I were to have numbers here, I'm just gonna do the multiplication real quick. Like
Okay.
I'm just gonna check my answer here. You can keep writing. I'm just gonna check. So if we were to do, we would have a 3x1 matrix, which was this right here. So in theory, if we multiply this by this, we should get this, right? So we should have this function right here, right? And matrix multiply, array 1, right, comma, array 2 here, and then click Control-Shift-Enter, because, and you see we get the same values here. So that's just a check. That's after you're done with everything, you could just check it like that.
Just check to get those yellow numbers down there. Right?
Yeah, so after you're done with getting these numbers, you could check. Like if you multiply this by U1, U2, and U3, you should get these numbers here.
That's those down there. There's another step, right? That's when you,
Yeah.
okay.
So this is the answer. These are the answers. U1, U2, and U3, these are the numbers.
How do you get the inverse numbers?
All right, so you highlight the whole area, right? So if you have a 3x3, you highlight a 3x3 area because that's the inverse is always the same size as the normal one. You do M
Oh,
inverse,
M
M inverse. If you want the inverse, yeah, M inverse, and then select the array, and you click enter. Oh, Control Shift Enter. Sorry, because it's an array. So Control Shift Enter, and you should get these numbers here.
Oh, I see. Okay.
So this is just the inverse. So since technically, okay, so what we have here, this is array C times X times R, which is what I have here, right? C times X times R. So if this was just a normal equation, we just divide both sides by C and we should have X, right? But you can't divide matrices. So what we do is we multiply by the inverse. And if you multiply a matrix by its inverse, you get the identity matrix, which is like multiplying times 1, right? So if we were to multiply this matrix by the identity matrix, it's going to return us the same values because it's like multiplying times 1. So if you multiply this by this, it'd be the same as multiplying the X times the identity matrix, which is just X. So technically, we pretty much canceled T out here by multiplying by the inverse.
Okay.
So X is equal to the resultant vector here times the inverse matrix.
How'd you get that formula?
Which one? This one?
Yeah.
I think that was in one of the PowerPoints or in one of the classworks.
Oh, okay.
Yeah. So you take this, you multiply both sides by the inverse. These cancel out. This cancels out right here. This cancels out. And now you're just left with this. The variables, or X here, is equal to R times the inverse of C.
So R is the 1,000, 2,000, 3,000?
Yes, this one here.
And you multiply that by all the inverse.
By this. Yes.
Okay. And then that's how you get the answers?
That's how you get this. So this is a 3x3, right? And this is a 3x1. Yeah, 3x1. So you can't multiply this first times this. So there's an order here. So let's say we're getting this right here. So M multiply, right? M multi. Array 1, it has to be this one. Because remember, the inside numbers of when you're multiplying two matrices, the inside numbers have to match. So if we do, okay, let's say we do this one.
Because it's 3x3 and then 3x1?
Yeah, so if we do this 3x1 times a 3x3, is that a period? Okay, times a 3x3, right? And then we could Control Shift Enter. You see it gives us an error here, right? Because we can't multiply a 3x1 times a 3x3. And you have to switch the order here. So you do M multiply, right? This one first, highlight this one first. So this 3x3 times this 3x1 here. And now if you click Control Shift Enter, you should get the numbers.
Got it.
So this should be switched around, like these two. Yeah, just make sure you're multiplying them in the right order.
Okay.
Yep. I think that's it for number 2. Yeah.
That's all that's needed for number 2?
Yes.
Okay.
Yeah, it just says find the displacements, U1, U2, and U3. Yep, and that's it right there. Yep. All right, so can we move on to number 3, I guess?
Mhm.
All right, so number 3. Let's see, at a cereal packaging plant, the target is to put 1 kilogram of cereal in each box, but obviously changes sometimes. And then says the boxes are weighed, data for a sample of 20 boxes shown in the following table. So these are 20 boxes, this is just 20 sets of data here, 20 pieces of data. And we have them all right here, all 20 right here. So it says find the mean value and the standard deviation. Pretty much just use mean or average. Average, you select the whole thing and you click enter and it gives you the average or the mean, yeah. Here you use standard deviation sample. She told us to use sample. I forget what the difference was between point like standard deviation S and then standard deviation P, but she told us to use S, so that's what I did here. Standard deviation S, and then you just highlight the whole data set and then you click enter and it gives you the value. So, and here's the count, here's the max and min, but that you don't really need that. So it says, so we found the mean and standard deviation here. For part 2, it says create a pie graph showing the frequency density distribution of this data, use bins of 50. So here's where the min comes in and the max. So our data here ranges from 863.5 to 1180.7. So we need to start somewhere that covers the entire set of data, right? So here I just started with 850 and then ended at 1200, going in bins of 50. So 850 to 900, 900, 950. Here you put in the upper values. So the top value here, that's what you're going to use for the frequency calculation here. So for frequency, you just, let me just hold up, I can't, okay. So let's just delete this real quick. So we're going to do frequency equals frequency. Then first you select the data array here, data. And then you select the upper values here. Right. And then since it's going to give you an array, so it's going to give you all these values here, you click Control Shift Enter. Oh, I didn't even highlight the whole thing. Sorry. So you're supposed to highlight the whole thing first. So highlight where you want your frequencies. Then you use frequency. There. Highlight the data values. Highlight the upper values. And then you click Control Shift Enter, and that should give you all the values here.
The first thing that you put in the frequency is the means, right? I didn't get it. Okay.
Okay. Yeah. So
Then,
let me just there. Okay. So you highlight the whole thing here.
right.
All of it.
Right.
You do equals frequency.
Mhm.
And it's here, see here, it's asking for a data array, which
Right.
is this right here.
Right.
And then it's asking you for the bins array. So this is where you put the upper limits,
Gotcha.
because Excel can't really do anything with this here. And then Control Shift Enter, and it should give you the values here.
And the upper limits is yeah, the upper limits.
Yeah, just the
Yeah.
top value here. So for relative frequency, it's just pretty much taking this number. Yeah, what's up?
You're going a little fast.
Oh, sorry.
It's okay. I'm a little behind, but the mean, what's the formula thingy?
Average. It's called average. Yeah.
And it's just the average of like all the data.
Yeah, you just highlight the entire data.
Okay. So we only need the mean, standard deviation, max and min.
You don't really need to put in max and min, just to know that where to start your bins, I guess, and where to end them.
Oh, okay.
Yeah, I just
And
need to cover 863 to 1180. So I started at 850, and counting by 50, I stopped at 1200.
Okay. And then for the bins, when you count how many of the data is in the bins, like the frequency? Oh, you used a formula.
Yeah, this one. So, right. All right. So you highlight the whole thing, all of where you want the frequency, right? You use the frequency function. Here it's asking you for the data array. So highlight the
Oh,
entire
I
data
see.
set.
And
Then
then the
it's asking
bins.
for the bins array. So you use the upper limits because Excel can't do anything with this. This is not a number technically.
Okay.
And then Control Shift Enter. Make sure it's Control Shift Enter because then it's not. Then it's gonna give you like a 0 down here. And you don't want that.
Okay.
Yeah. So for relative frequency, you just take the frequency of that bin and then divide it by the total amount of data points. So you take this right here. Oh, yeah. So set this equal to the frequency divided by the count here. And this, the count, it tells you the count here, 20 boxes, but sometimes it doesn't. So you could just use count, and you highlight the entire data set.
Okay.
That's the total number of points or data. So the relative frequency is equal to the frequency of that bin divided by the total count. And if you want to be able to drag this down, you have to lock the count here. So F4. You click enter, you see it's 5% here. And then you just drag it down. Now you have all these frequencies. And
My bad. Can you step on the frequency so I can copy the formula real quick?
this one,
Yeah, just step on it. There you go.
uh,
Yeah, it's
it adds the little brackets. I don't know if you like.
no, I'll get it like that.
Yeah. So the brackets it adds when you press Control Shift Enter.
Yeah, it's just selecting the beams and the data.
Yeah.
Yeah.
I'm sorry. Can you show how you did the relative frequency? What do you do?
All right. So if I can get out of this. All right. So you take the frequency of that bin. So relative frequency is just pretty much the frequency of that bin compared to everything else. All these add up to 100. All right. So you take the frequency of the bin, so it's 1, and you divide it by the count.
Oh, right.
So it occurs once out of 20 times, so out of 20 data points. So 5%. You divide 1 divided by 20.
Okay.
And if you want to drag it down, then you have to lock the count because you don't want this moving from here.
Oh, you gotta lock the count when you do the relative frequency. Okay,
Yeah,
gotcha.
because you don't want it moving from here, but you want this moving. You want it to move down as you drag down.
Right.
Yeah. So
How do you
then
make it percent? Is it the number thingy?
yeah, so you just
Got it. Got
highlight
it.
the whole
Never mind.
thing, change it to percent. Yeah, right here. Percentage. Oh. Right.
Oops, I put this wrong. Oh my god. Oops.
Yeah, it's gonna give you a decimal, so you could just change it to percent. So part 2 says to create a pie graph. So this is what the pie graph looks like. So you just highlight the entire values here, insert pie graph, and you notice it says the labels here 1, 2, 3, 4, 5, 6, 7. What you want is to change those labels to the bins here, so you know what all of these represent. So you can go to, actually, here. You right click or you double click. I don't know if you guys are on a laptop or PC. So you right click or you tap with 2 fingers and then select data. And then here, right here, for pie graphs, they're called categories. So these are the names of the categories 1, 2, 3, 4, 5, 6, 7. So what you want to do is change those from the numbers to the names of the bins here. So you're going to go to edit. And now it's asking you for the access label range. So instead of 1 through 7, it's going to be these labels here. And then you click OK, and then it changes all those labels to the names of your bins. Let me see how it changes here. Then you just click OK, and now you have that. You could also have the data labels, so it shows the percentages on the pie graph, and change the title. And that's it for part 2.
Wait, what about the midpoint thing you have there?
Yeah,
And the
yeah,
normal
that's for part 3.
Oh,
Yeah, there's 3 parts to the question here.
oh, and you're
This one.
moving on to the next part?
Yeah, part 3 right here.
Oh, okay, sorry.
Yeah, yeah. So the probability density function is the PDF here. So according to what she told us to do, we take the midpoint of these bins. So 850 to 900, the midpoint is 875, right? And then you could do it as I did, where you just add these two and then divide by 2, or you could just add by 50, because that's what it's doing here. 875 plus 925 plus 50 is 925. And 925 here is the midpoint between 900 and 950. So you could either add these two, divide by 2, and then drag the equation down, or you could just set this equal to this one plus 50. And then it'll give you the same number. You could drag it down, it'll give you the same numbers. Either way, you just need the midpoints here. So now what you do is you take the relative frequency. So in this case, it's 0.05 or 5%. And then you divide that by the length of the bins. So between 850 and 900, it's 50. So you take the relative frequency and you divide by 50. And that's how you get that number. And then you could just drag it down.
The PDF or relative frequency divided by the
length of the bins, the size of the bins, I don't know what you want to call it. In this case, it's 50.
So,
yeah.
Apart from like the actual question, how did you know to do that for number 3? Because if I were to give like, let's say this is the test and I read that third part, I would not understand how to do it. Did she explain it to you, or did you like get it?
That was one of the classworks where it let me see if I think it's classwork 3. I'm not really sure. If I could find it here. Yeah, it was this one. You see this probability density function. So if you want to look back at the video for classwork 3, here she found the midpoints. You see 48.5.
Yeah.
And divided the relative frequency by 7, because between 45 and 52 is 7. So that's the length of the bins, it's 7. So that's how she found that. Yeah. So if you want to look back at that.
Okay. Thank you.
So that's a PDF. So it says compare with the normal distribution for the same range of values. So if you want to compare them, best way is just to plot them, right? So we need to also find, actually, let's plot it first. So you select the data, click insert, go to, what am I doing? Go to scatter plot here, just draw a line. So you could also change this right here so it's don't have so much dead space. Forget if it's 800 or something. All right, so we'll start off at 850. See, the graph is still on the And we have that right there. This is what we have here. So you had the title, you had the axis title, and you could also add a legend here. So we have our PDF there. And for normal distribution, we pretty much just pick a range of X because it doesn't really matter. We could start it off at 700, but we just need to find the range that covers all the values here, right? So we start off at 850. You can count by as much as you want, but I just continue counting by 50 here. 850, 900, 950, all the way to 1200. And then here you just use this formula here. Normal distribution. It's in that same classwork video. I forget if it was multiple parts, but it's in that same classwork 3. So you click norm distribution here. And here it's asking you for the X. So I wanted to plot it at this X value. You go to the mean. You click the X, you put a comma, then you select the mean. The mean is this, comma. The standard deviation, this one right here, comma. And here it's asking you, do you want it to be cumulative or not cumulative? So let me see if I can get the classwork 3 back up. Oh. Wrong one. I'm just opening the wrong thing. All right, so here. Will it open? Guess it doesn't want to open. Let me see if I can.
Didn't you already have it open?
Yeah, I did. I just closed it. I don't know why. Well, I guess Excel doesn't want me open. Okay, there it is. I don't know. I guess putting in a formula prevents you from opening stuff. Kind of weird. But here, we did PDF here, but we also did cumulative normal distribution. So you see how we have, this is the normal distribution, the one we need for part 3. But there's also the cumulative normal distribution, which pretty much just adds the values as it goes. So at 70, it's pretty much adding all these points and then getting this value right here. So if we want it specifically at 70, we could just look at this normal distribution right here. But if we want to know what's the probability of getting any values 70 and below, you look at this graph right here. So you take the area between under here and you figure out the probability of anything under 70. So there's the difference there. So this pretty much accumulates as it goes, and this one just gives you the probability at that point. So in this case, it's just asking us for a normal distribution and not for the cumulative normal distribution. So let me norm distribution, select the X, comma, select the mean, comma, standard deviation, comma. And then when it's asking you, do you want it to be cumulative or not? You put false because you don't want it to be cumulative. And then click enter. So then you could just drag, actually, before you drag that equation down, you have to make sure you lock the mean and the standard deviation here. So you don't want these moving around, but you want this one to move around. You click enter, and you just drag it down. It should give me the same values here.
Wait, so you put X, the mean, the standard, and what else?
So X, mean, standard deviation, and it's asking you, do you want it to be cumulative, true or false? So if you want it to be cumulative, you put true. And if you don't want it to be cumulative, then you put false.
Okay.
You just click enter, and then you could drag it down. But make sure to lock your mean and your standard deviation before you do that.
Oh, you're right.
Yeah. And then if you want it, are you caught up or?
No, what do you lock? Sorry.
The mean and the standard deviation, like if you wanted to drag it.
Oh, okay.
Yeah.
Got it, got it.
So you don't want
Thank
these to move. You only want this one to move down.
Yeah,
And then false for not cumulative.
got it.
So now if you wanted to add these values onto this graph to compare them, like I did here, you just go to select data. This is where you go to change the labels or add another series of data. So another line or another chart on here. You go to add. Then in this case, you could just call it the normal distribution. Highlight the X values here. And then here you gotta make sure you delete that one and then highlight the Y values. Click OK, and there's your chart. And this one you can rename. Edit, rename. This would be the PDF. Okay, okay. And when you add the legend here, it should give you the names of the series.
What lines do you pick for that chart?
You go to scatter and then you click either
Oops,
one of it. Doesn't.
Okay, because I picked the first one.
Oh, you just click the dots.
Yeah.
Yeah. So either one of these works, I guess.
Okay.
Yeah. And then you add the access titles and then the chart title. And I think someone yesterday was telling me that as long as it's kind of similar, because the question is asking, would you use the normal distribution as PDF for the data? So it's asking like, so this is the actual distribution of the data from the data set. This is the normal distribution. So this would be like an ideal distribution, I guess. So they're asking, can you use this normal distribution in place of the actual distribution? Like, are they close enough? Like, do they resemble each other enough that you can use them instead of the actual distribution? And I think someone said, like in this case, yes, as long as it's kind of similar, then you can, but don't quote me on that. So I would put yes here, but with like an asterisk there, like I'm not sure, but
All right, hold on, because I'm redoing my chart really quick.
yeah, it's fine.
Okay, you can continue. Thanks.
All right, so number 4 says the total drag force in an airfoil can be estimated as this equation right here, where D is the drag force, S is the air density ratio, W is the airfoil weight, and V is the air velocity. So it gives us the values of S, W, and it tells us to plot D as a function of V. So D is pretty much our Y value, and V is our X value here. And it gives us a range of X here. So 100 to 1,500. Notice that there, so just first plot this. So you take all these values, go 100, right? 100 to 1,500. You write down your values of S, you write down your values of W here.
When it tells you, my bad, when it tells you plot whatever as a function of whatever, that means the what are you plotting is the y values, right?
Yeah, so if because usually used to seeing like f of x, right?
Yeah.
So f is the function of x, like you know,
Yeah.
so this is your y,
Right.
but as a function of x here. So that's what it is.
All
So here it'd be dv.
Yeah.
Yeah, like that. So you're gonna write down your v values here, 100 to 1500. I just counted by one, I mean 100. And here on this side, you write down your equation. So it's, according to this right here, let me just rewrite it actually. 0.01 times s times v is right here, but it's b7. So times v here squared plus, and then you could just put this in parentheses just to make sure there's no weird calculations going on. So 0.95 divided by s. Then you close that parentheses. Then you multiply that by, you can close another parenthesis here, w divided by v, which would be here, b7. And then you square that. Oops, square that. All right. So if you press enter, you should get the answer here. But if you wanted to drag it down, you would have to lock s and w here. So all these blue numbers, all these blue cells, you would have to lock, that's s. And then for w, which would be c4, you have to lock both c3 and c4 here. You could leave b7 open so you can drag the y values down as well. Yeah.
For the B, you only use the 100 one, the one, the first one.
Yeah, and you can just drag it down and it'll calculate all these v values.
Okay, let me write it down real quick.
Do you have to get the minimums? Oh wait. I see it in the question. I didn't read the whole thing. Never mind.
Go ahead.
All right. So you obviously got all these d values, and then you would just plot it pretty much. So highlight the entire thing, insert this one, and then, I mean, I didn't do it, but you could format this, remove all those 0 decimal places here, add the access titles, change the chart title. So now you have this plot here. So it says, notice that there is an optimum velocity where the drag force is minimum. So it'd be at like this point right here somewhere. So this is where the drag force is minimum. So you have to determine the minimum drag force, so determine the y value and the velocity, so the x value at which this minimum occurs. So what you're gonna do this, what you're gonna do here is use solver or goal seek. Actually, not goal seek, use solver, because so here you could just guess, like it's around 500 where this minimum occurs here. So you could just put 500 here. And here you could just copy this equation here. Before I just copy this, paste it here, right? But make sure that you're using this value right here instead of the 1500. Actually, what am I doing here? 15.
Can you explain that part again?
All right, so what you're gonna do here is pretty much just what you're trying to do is find the minimum here, right? So you're just gonna guess an X value where this
Right.
minimum is,
Right.
just 500 or something.
Yeah, yeah, yeah.
And then you're gonna evaluate the equation at 500, which is this right here.
Right.
So this is just their starting point for solver. So you go to data, go to solver. So you want, this is your objective. So this is what you want to minimize in this point, in this case. So you want to minimize this value. This is your drag, the drag force. You want to minimize it by changing this velocity value here and nonlinear. And then you just press solve, click OK, and it should give you the value. So you see,
Go ahead. Go ahead.
no, it's fine. Go.
The minimum value for D is the same equation that we used at the beginning, right?
Yeah, it's all the same question. This one, this question. So now that we use the solver, it shows us that this is the minimum drag force value. And it shows us that that minimum value occurs at 509.82. I think it's like meters per second. Actually, there's no units here. So at 509.82 velocity or speed or whatever. So if you want, you could plot that. You could, like I did here, you could just add it here. So you go to select data, add. You see how I have it added right here, optimal velocity. But if you add, just write minimum or something. You click the X value here. And then here you delete the one, click the Y value, select OK, press OK, and notice how it's not going to show up here because it's a line. If you just click legend, you see it's just a line, so you're not going to be able to see it. So if you want to format it, so it shows a point. So you go here, you format the chart, and then you go to where it says minimum is what I just called these points I added. You go to marker, and you see how there's no marker right now. You just add a marker. Here you can make it really large if you want. So this is the point I just added. Made it a triangle here. And you could also add data labels, which is what I did to get this right here. If it will show up. Okay, then. There it is. All right. So you could add the X value, which is the speed at which occurs, and then the Y value, which is the value where the drag force is minimum. And then you could show the series name. So if you called it minimum, it's going to show up here, minimum with the X and Y values. You could center, you could put it on the left, you put it on above it, below it. And that's it for problem 4.
I'm getting like a crazy lot of like labels in that last part.
Yeah, so you pretty much you're getting all the labels for all the things you added here. So just actually, let me just undo everything here. All right. So what you can do is once you get your point here, I guess you could just double click on it. And what am I doing? No,
Well, actually, how do you get that point?
Okay, so initially, if we were to plot this, it would give me a line. So you wouldn't be able to see it. So let's say you can't click on it because it's a line, it's hidden under this one. So you just go double click on here, format the chart, right? And here you go and you look for the whatever you called it. So I called it optimal velocity when I plugged in these 2 data points. I mean this point. So I called it optimal velocity. So all the options are gonna be under here. And then you go to marker, and
Mm.
usually it's gonna have no marker here. So it's just gonna be a line. But if you want a dot there, a point, you can set it to automatic or built in or whatever you want to make it. So
Well, I didn't actually realize you put the thing like as data.
oh
So is like the X the 509?
yes, that's the optimum velocity. That's where the drag is minimum.
I put it, but nothing came of it.
Like you added it to the chart.
I added it to the data, like select data.
So like you added it here, but it won't show up. Is what you're saying?
Yeah.
So it did that because it added it as a line. So it's gonna use the same format as what your other data series is. So it's just gonna give you a line. So if you let's see, I'm just gonna call it X for now. So you add the X's, I need the X, you add the Y, you click OK, and you see it says it's there, but I don't see anything, right?
Mm-hmm.
So what you would do there is go to here. You see I called it X.
Uh-huh.
You go to marker, and it's just not gonna have a marker because it's using the same format as the other one.
Oh,
So it's not gonna have a marker. So you add a marker.
yeah, I see it now.
You see how there's a gray thingy there?
Yeah.
Yeah. So just do that.
Okay.
Yeah.
Got it. I have the dot.
Yep.
And then what's the next step?
So that's pretty much the last step. Find the minimum drag force, which is this one, and
Oh,
the velocity at which that minimum occurs. Like that.
My bad. Look, can you click on the minimum again? See the question real quick.
For what?
So the minimum.
Oh, for this one. Okay. Yeah.
You had to change something up there, right?
All right. So, I mean, the easiest way would be just to wait. Hold on. Like, so you could just drag it down. Take this and then drag it down.
Oh,
Yeah. But and then just fix this here.
yeah.
I mean, I don't know how. Depends on how you do it. So you just merge in sensor and you just put them in.
How did you do it again? So I can see your weight.
So if you set it up exactly like this table right here, you could just unmerge this because you can't drop down into a merge cell.
Right.
So you take this, you just drag it down, right?
Yeah.
And it's gonna evaluate it at 500, like before you do use the solve. It's gonna evaluate it at 500. In fact, let's do it now. So it's gonna evaluate it at 500, right?
Right.
And then you just merge this back and fix right there. Now you have that there, and then you solve it. Yeah. We want to change this value. I mean, we want to make this value a minimum by changing this value right here. All right. And then nonlinear and just press solve. It's okay. And then you should have your values there. Yep.
Okay.
Yeah, when you use solver, always make sure to have the equation here.
And you're locking only the S and W value up there.
Yes.
Gotcha.
Yep.
Okay, so now I'm gonna go ahead and do all of this. Now that I know how to do it.
All right. Good luck.
Question to you: are you recording this?
Yeah, I did.
All right. All right. So yeah. So I can follow up if I have any questions. I'll just pull up the video real quick.
Yep.
Thank you, brother. Been
All
great.
right. You're welcome.
Hey, thank you so much.
Yep. I mean, I think I've done problem number 2 for the homework. I don't know if you guys want to see that real quick.
Oh, yeah.
All right, so
Or homework number 2?
yeah, I've only
my
done
God.
number 2 because I honestly haven't done the other ones, but
I
So
was
this one.
gonna say, like, if you wanted to do like as a group, we could put all our brain cells together to
yeah,
get it.
yeah. Because okay, so I get how to do number 1, but like, do you just look at it and be like, okay, so it's at 0.1, 1.3. Is that how you do it? Like you just take 10 points just looking at it?
No,
I haven't even looked at homework number 2.
Yeah, me either. I
Oh.
really don't know.
We could-
how to do it.
if you guys want, we can meet either tomorrow or Sunday and go over the homework.
I'm
Yeah.
down. I'm down.
Yeah,
Like-
someone said they wanted to meet tomorrow or Sunday. Yeah.
Yeah, that works.
Like over
That
Zoom.
works too. Yeah,
Yeah.
to the homework. Yeah, I'm down.
And
I'm so down as well.
yeah, so tomorrow Saturday we can meet, and then Sunday, if you guys want, we can meet again and
Yeah.
study together.
Meet again, just meet every
Meet
day.
again to like review. For the-
Yeah.
Yeah.
Mhm.
All right, well, thank you
guys.
so much.
Thank you guys.
All right. Yeah.
Appreciate that, everyone.
All right.
I don't know if it's just me, but this teacher puts a heck of a lot of homework.
Send the link that you send through the group. That's the one, right? It's gonna be there
For what?
to see the recording.
Yeah, I'm just gonna send the link.
All right, cool.
It might
Appreciate
take
that.
a while to not look
Don't
like
worry.
garbage, but it's gonna
Don't
be like
worry.
320p for a while.
Don't worry.
All right.
Thank you, Rich.
Yep.
Thank you so much, Rudy. If anything,